Good afternoon. My name is Tanner Elfelman and I'm representing Team 9 for our third and our final presentation of the block clock. Today we'll be going over a couple things. First, I'll give you a review of what has already been touched on the previous presentations. Then after that, I'll give a quick presentation on the intellectual property of the block clock, our FMEA, our BOM, our CAD drawings, our final prototype, a reflection of our product and how we can improve on it, and an overall conclusion. First, for a review. Our mission statement stated that we wanted to design a multi-purpose desk clock that would also serve as a lamp. But not only that, it would be a spectacular display, mostly just for college students, considering that that is our target audience. Our customer statement came with a lot of ideas, as you can see, but the ones that we mostly wanted to touch on were that it was affordable, it was durable, it was easily able to move, it provided a sufficient amount of light, and it served as a very accurate clock. As you can see, that is what we came up with for our specifications, and under each one, for adequate light source, we lettered it in lumens. Display the time accurately, it was either a pass or a fail. Low cost was in USD dollars. It was durable and reliable, which is also a pass or fail, and portable, which was measured in weight. As you can see here, we have our profit margins, and off of this, we decided that we wanted to sell the item for about $35, considering that the variable cost for each one was about $25.62. Our break even would be at about 1,067 units sold, and we expected to sell 1,500 units, which would overall an annual profit of $4,070. For our mind map, we came up with multiple different ideas and kind of started branching out, but there were really 4 specific concepts that caught our eye. And those were how it received energy, the clock display, the received input, and the light type. Based off of this, we gained 6 solutions, which then brings us to the screening. Off of those 6 solutions, we did our screening process and we ended up with just 3 solutions. Then off those 3 solutions, we did the scoring method, and the winner was solution 3, the light cube, or as you formerly know it as the block clock. As you can see here, this is our final design. It featured an internal battery, LCD displays, a button, and an LED. Now let's touch base on our intellectual property. There were 5 patents that we worked with, and those 5 patents went into the area of making the block clock USB chargeable, brightness controllable, the use of bendable light strips, and a digital clock display, which were all used in our final product. For our failure methods, there were 3 main failure methods that we found. 2 of the methods were just due to poor quality, and there are multiple solutions to that. We could use better materials when designing our product. We could also leave a warning that the block clock is a durable machine, but you can't play with it. Our bill of materials. Overall, in the price breakdown, it was a little more than we had hoped, but there are multiple ideas of how we can knock down the price. The first one is creating a quicker and more useful way of creating the base and the semi-transparent cube around the light bulbs. How we would do this was most likely through mass production using molds or 3D printing methods. Our second one is that small and finished parts are much cheaper if you just buy them from third-party companies in large quantities, as opposed to making them yourself. And our final one is bulk items, such as the LEDs that we used, are far cheaper. Here we have a presentation of our three-dimensional CAD drawing. This was created in Inventor, and as you can see, it has all the included parts of the block clock. Here you can see the base of the block clock, which would feature an LED display and buttons on the side that would allow you to control the light and control the clock on the front of the interface. On the inside of the block would be all of our internal components, such as our Arduino, our heat temperature measurement, our humidity reader, and all the internal wires that led up to the LED and the display. Then here around this tube, we would wrap our LED lights around it to create an even display when displayed out by the clock. And then our shell here is the base for a semi-transparent thing that we would overlay so that you don't directly see the lights, and it would disperse the light out across the image. And here is an example of our final prototype. We presented this in class, and the base was created using a 3D printer, and then we took a separate piece and created another flat thing using a 3D printer, and we had a cardboard tube that went out throughout the base of the product. Then on that cardboard tube we wrapped LED lights around it, and then we took tissue paper, which again is not very durable, but this was just a prototype, and we wrapped it around, which left the lights underneath all luminescent and displayed. And then as you can see here, we also have our clock display that tells you the time, the temperature, and the humidity. And then theoretically we would have buttons in here, but since it was only a prototype, we just had a separate controller that allows you to control the lights and the clock display with just the push of 4 simple buttons. An overall reflection on our product: we believe that some improvements that could be implemented onto the design are a phone charger port that could be plugged in to the device, an alarm system that would not only display an alarm at a specific time set by the user, but would also flash lights at the top of our clock. If we were implementing an alarm, we also wanted to make it have sounds, so not only would it just have the regular sounds of an alarm, but you could also turn on the radio per se, or just make fun little interesting sounds just to pass the time. We also wanted to make it Bluetooth available, possibly add a speaker to it so you can connect your phone to it, but also be able to control the clock via any kind of smartphone you own. And finally, we wanted to make it wireless because we wanted to implement more of a portability on it to where you could place it wherever you want. So instead of having it plugged into a wall, we would use internal batteries. A few other concepts that we wanted to touch on were an antique wooden style design that would use Nixie tubes to display the light, or my apologies, the time, and would use an old-timey light bulb on the top to produce the light. A couple other ideas are the party box, which served the same purposes, but instead of telling the time, it just made a party. So it had a disco ball on the top that would flash lights all over the place, and it would play music through it. We also wanted to make a more child-friendly design so that it could be used by a more younger audience. A heavy multi-purpose design that would not only have the light, the temperature, the time, and the humidity, but it would have multiple more features. And then a more sci-fi kind of thing that's not as much of a modern look, but as a out-of-this-world approach to it. In conclusion, as Team 9, I believe that we evolved a lot throughout the semester. We learned a lot, not only about the entire design process, but how to work as a team and get the job done. My name is Tanner Offelman, and this has been the DP3 presentation.